Welcome to Morehouse Metrology Matters. Today we have Ryan Kelly. I'll be speaking with Ryan Kelly, who has a lot of experience in metrology. Ryan is an assessor for ANAB and has worked at various calibration labs throughout his career. Ryan, do you want to add anything to that?
Currently became the vice president of lab operations for NCLSI. So I oversee 7 different committees. So new role, excited about that. Hoping to make some positive changes, to the committees and garnish more membership.
Yeah, so if you're listening, that is a good way to get involved and actively involved because some of the things that we're going to talk about today do involve that. And people are struggling making measurements, right? Depending on what committee it is. I know I sit on the airline committee, and people say, well, we got to do this. The FAA requires this. And you're like, okay, but it's not feasible for us to do that. And what they're saying, there's all these different scenarios where the power of these committees hopefully can produce the data and change some of the regulations when those regulations are unfair.
Right, and NCLSI, being as big as it is, typically has a seat at these tables with ANSI, with ASME, with ISO. So, I believe Jeff Gust was selected, and he got to write portions of 17025, 2017 when that was coming out.
Hmm.
ISO sent him to be able to do that, and he's our current president now. So these opportunities that people get being part of NCLSI, you get to interface with subject matter experts like yourself, right? You're the force guru everyone goes to. So, that's how
Hopefully.
you yeah, and that's how you and I met was, me going to these conferences and just, saying hello and interfacing and then,
Right.
going out for beers later and having fun.
We don't do that. We do none of that. So
No, no,
we've
no. It's
never done
all,
any of
all
that.
never, never.
No, it's always fun. They have different NCSLI, good organization, but the people out there should really get involved because there's a lot of complaining, and you'll hear it like us complain too about industry and taking charge and change happens slow,
Yeah.
right? It's pretty slow to implement. People don't get it. In addition to it being slow to implement, the standards committees sometimes they run a bit faster than industry runs. And one of the things that Ryan had posted on LinkedIn that we were kind of talking about was TAR. And people that know me, I do not love TAR, test accuracy ratios. There's a group of people that do love it and still use it. Though when I talk about the standards changing, we had ANSI Z540.1, which talked about TAR. The rumor is that it should have been TUR. Then ANSI Z540.3 comes out in 2006, I want to say, right? Is that
2006. Yep.
2006? That discusses TUR. And then JCGM 106 comes out, I think, in 2012 and starts saying, hey, there's so much of this ambiguity between TAR, TUR, and things aren't really properly defined. So now we're going to just say the heck with it, and we're going to call it measure. We're going to call this concept measurement capability index, which I think best defines things because what we tend to do, and Ryan, get your input on it, in this metrology world, we overcomplicate things, right? That we don't need to overcomplicate because a lot of these statistical tools are already out there, right? They've been out there for maybe a century, and then we rename them something else for metrology purposes instead of what is it in I guess ASME what conformity the now I'm drawing a blank. It's I
Is it
think it's
CPK?
no, it's
No.
conformance and I think it's conforming. Yeah, that's what it is. So it's conforming and non-conforming, and a lot of manufacturers would use that, right? Or they would say it's a defect. So we in our world start saying, oh, what's when we start calling probability of conforming or probability of non-conforming, we change that to these terms like conditional and unconditional PFA or FAR, false accept risk, and we start varying from what they're doing. But the concepts are generally the same, and that creates a bit of a mess linguistically.
Right. And on that post, I think Michael Johnston kind of said it best, it kind of comes down to what your customer wants and the risk that they have, right? but also to, advocate to your point, there's so many different terminologies out there. It's like, okay, we kind of all have to agree on the same terminology because it's going to get confusing because your healthcare, customers are going to say one thing, your airline's going to say something else. And then depending on what, if it's government work, depending on if it's an older application or newer one, you might be talking TARs, they might ask for .3, they might ask for 17025. You might be all over it. And all of a sudden you're talking, hey, they want TARs, they want a 2% PFA, they want
Yep.
a 1.33 CPK value and stuff like that, and you're like, and it's like, all right, it's all trying to get to the same point of mitigating risk, but I think everyone kind of needs to get on the same page. And it's to the point where, we talk about, let's use the standards as an example, right? You had dot one came out, and then shortly after that, you had ISO 17025, 2005 edition, right?
Yep.
But
Hmm.
then we said, no, that's not good enough. We can take it further. So then dot three came out. And then all
Yep.
of a sudden, 17025 2017 incorporated a lot of dot three, but left out, the 2% PFA. They said, hey, that's a decision rule, leave it up to your customer, right? There's multiple decision rules, pick whatever. And to that point, Americans, we were like, no, it can still be better. And we almost try to do a dot four. And it's one of these things, it's like, hey, instead of just trying to outdo everyone, just everyone get together and, try to get on the same page. I don't know why everyone's got to try to get like, no, ours is going to be so much better. It's like, no, let's just work on one process and collaborating to make it the process and probably the best process.
That would be great for people because they can't keep up. I mean,
I
you
know
have all these
it's
standards.
wishful thinking, but
I,
it's
yeah. I mean, you
enough
can't.
pe with
Yeah.
enough people we can get there. And I think I hate saying this, but I think when some of the older generation starts to retire, we might see more of that collaboration because some of
Yep.
those people are the gatekeepers and they're key holders, and we're not going to be able to get that change because they're dismissive, upfront about it.
And they've always done it that way, or they don't want the headache of rewriting it. I mean, being on a committee, which I was fortunate enough to be on with you on the LM1 committee, that's laboratory management, where Ryan was had everything up. He had to herd all the cats, I would say. And what the NCSLI was giving you things like, let's add this, let's add that, and and then you got some pushback from us on some of it. I know, like, why
Oh
are we
yeah,
doing
no,
that?
exactly. I mean, the nice thing was like that's another great thing about NCLSI with that membership is you get access to these documents that we're talking about, LM1, which is, laboratory management, document number one. And I think
Mhm.
there's 21, 22 of them, and they all
Right.
cover different things like, delay dating, how to do a calibration interval analysis. So it's things that are super beneficial to labs, especially if you're a junior lab, starting up, or hey, this is your first time as a metrology manager. Well, LM1 is going to be a good document because it's going to go over the basics and then point you in the direction of the more in-depth
Yep.
documents. So, we're going to talk about, I'm looking at it right now. It's going to talk about calibration procedures, and then that should direct people to look at maybe RP3, which is almost a 90-page document on how to write cal procedures,
Yep.
or RP13. We talk about calibration intervals. That the RP1 was heavily talked about. That whole document is about cal intervals. But we also noticed that some of this information was outdated, so we started to add in more sections that were relevant to newer things. So talking about supplier relations, right, and how you
Yep.
manage that, and kind of maybe supplier vendor scorecards, right, the very basic thing, how you assign risk to a vendor and determine whether or not they should be an approved vendor for you to use. Emergency recovery planning, what to do in the case of a hurricane, some type of disaster, even COVID, right.
The
um
fires, Keysight was in the fires, which
yeah. the,
they did an excellent presentation, and I think was someone part of there was representative Keysight on that commit on LM1, right?
Yes,
Or
actually,
yeah.
that the LM1 reports up through John Harbin, the
Oh,
vice
okay.
president
Yep.
for
Yep.
that. So yeah,
Yep. Yep. Yep.
he's on that. And we start to go into more things like recruitment and releasement, how to try
Yep.
to, recruit the best people, and then, the proper way to
Cybersecurity.
release someone. Cybersecurity was one. I
Yep.
know you and Greg were working heavily on the reliability and end of period reliability.
Yep. Yep. The overview of it, not
Yes,
getting
yes, the
heavily into the statistics that Greg Senker is the statistics guru that he is.
yeah,
Uh, yeah, we can.
not going into the dissertation, but an
Yeah.
overview for like, hey, these are terms you should be aware of, and if you want to learn more about it, all right, Morehouse has this document about it, or
Yep.
IndieSoft, where Greg works, they have this information
Yep.
about it, so because you guys have done great presentations on it. I think I
Thanks. Yeah.
ended up getting the actual book that you guys printed, one of the copies during the
Oh, cool.
conference.
Yeah, I'm
Yeah.
working on another one now. Oh yeah, yeah, the decision rule book that we all did. And that one, that was an interesting collaboration. So Dilip Shaw, Greg Sanker, and I do decision rules. And this is getting into like some quality in your quality hat here, not to go away from NCSLI because I think everybody should realize that they should join the organization. They get the RPs and everything else.
Well, plus
It's
it's inexpensive to join. I think a single
yeah.
person membership is 200, maybe $220 a year, and I think a business membership is $1,000 a year for
I
10
want to say
10
it's a
people.
little. I want to say it's a little less. I don't know. I don't know off the top of my head, but it's
Either way,
not.
it's inexpensive for a yearly membership that gives you access to all of this documentation. You
And
know,
free webinars, metrology and motion webinars, where
yep.
you have experts talking. They had one. They talk about intrinsic standards was their latest.
Yeah, that
You
was
get
today.
you get
I was
yeah
listening to that before me and you
yeah
got
yeah
on the. Yeah.
yeah. So they have like a lot of good things. And if you're starting or in the lab, just the plug for NCSLI, I mean, those documents alone, and if you want to cheat a little bit, you could feed them into a chat GPT because guess what? They are finally not locked by Lock Lizard, which was the sucked.
Yeah.
Especially when you download a document and then you're the only one that can view it, that really stinks because you want to share it with your team and everybody else, and or you want to copy and paste sections out because you want to cite it because there were excellent people on those committees drafting those documents and there's some really good stuff in there. And the PDF tool they used to use would you even copying and pasting, you'd have to retype everything, and it was just
Oh,
it was
even retyping became difficult because it would blur out the PDF if you went into another app. So all of a
yep
sudden you'd
yep.
be trying to write it in Word. And then if you did more than like 3 downloads in a month, you exceeded your downloads for the month. And
And
you're
then you
like,
had to get permission and everything else. So
yeah,
that's all gone. We
yeah,
shouldn't even. It's all gone. If somebody had bad experiences, it's gone. And now you also get access to all the high level papers and everything else that were published through Metrologist and Measure.
yeah. All the
So
old conference papers,
oh,
all
they're
the
so
old, yeah.
awesome. Yeah, to dig them up, like Jeff Gus will talk about them. Oh, here's a great one to read, and you're like, well, that one's hard to find. And then, but NCSO, the cool thing is NCSOI has most of them. So if you can dig them up, sometimes you can
Some,
dig them up without NCSI membership. So
yeah, sometimes
uh,
they'll reference it and I'm like, cool, I was in high school at that point, but all right.
uh, yeah, yeah, Jeff can recite some of those things. So anyway, uh, so yeah, I wanted to move on a little bit, and now I forgot that train of thought where we were going on that from the TUR document and stuff. But Ryan's done some interesting things and some interesting emails for people out there. Like Ryan's sought feedback for some things, and the last one Ryan sought feedback for was really interesting because it was a torque application where it was a pass fail application, and it was based on do you fail something or pass something conformity assessment that we were talking about, based on averages or individual measurement points. And that's a really interesting discussion. And before you get into that, Ryan, the one discussion I had about it was hilarious, and that I can recall and it was a gentleman from this. I'm not going to say who it was, but they were able to get it was truck scale application, and we sat down for lunch, and he was saying this manufacturer is just this garbage. It's like I wanted to see how they got their numbers. So when they went and looked into how they got their numbers, they shared everything with him. And here they based everything on averages. So on average, the spec was X. But if you looked at the variation of the device, it wasn't that way. And our conversation was funny because it's used to weigh trucks. So what are you going to do? You're going to ask the driver to keep circulating around, right? Oh, wait, we got to do three measurements here. So just, hop on the road and drive around in a circle and we'll weigh you again. So yeah, it's uh, quite an interesting, thought process there with that one. Though, what did you find with the torque? Because that's
So
none of them.
it was interesting. So some responses were, we do provide an average on there, but conformance is based off of individual measurements. And there were others that have said, oh, we just base conformance off of the average. Now, that raised a concern for me because I was familiar with the ISO document and I believe it's ASME document that covers torque. And nowhere in there does it discuss averaging at all, right? Everything's
Right.
based off of individual measurements. I believe even the Japanese document, it's JJG something, same with them. So, or yeah, I think it's Japanese. But essentially, all of those documents say that everything is based off of individual conformance. Now, they go into the difference of how many times you might need to exercise it, right? Or the number of measurements,
Hmm.
depending on the device, and it's similar between ASME and ISO. ASME has a nice chart at the back of it that says, okay, if it's a type 2 class B, blah, 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 it's this in ISO, right?
Yeah.
But you would also find out that looking at the specifications, it might be 4% in ASME, but in ISO it's 6%. Or in ASME, when you go counterclockwise, typically, it's always 4% clockwise, 6% counterclockwise. Everyone's used to that with your typical like snap-on CDI, snap
Right.
type
Yeah.
wrenches.
Yep.
Um, ISO doesn't do that. They say it has to be 4% both ways. So yeah, you get these interesting differences, but when you start to look at it, it's okay, well then why did we start averaging it? And some people would point to guided procedures, so the military, right? Which
Yep. I've
military
seen
is
some
right, but
tensiometers are one that I've seen where.
and even the military contradicts itself because
Yep.
depending on the NAVAIR or TO document. So NAVAIR is the Navy and Marine Corps, and then TO is the Air Force. Even with NAVAIR ones, there's only two documents I found that said average, but then there were other documents that said base it off of individual. And when you look at the scope of those documents, you could use the same wrench with either one of those. So it's like,
Mhm.
well, depending on that, you can get different results because, let's say you
Oh
did
yeah.
5 measurements, I could have two that are out of tolerance, three that are in, and my average is good. Or, let's talk
Yeah.
worst case. My standard deviation between the measurements could be horrible. They could all be out, but my average would then almost look dead center, right? But
Yeah.
then,
Yeah.
if
Because
you
you could
look
be
at,
super high, super low, and that can
right, and
happen. That was the
it,
truck scenario: super high, super low, and on average.
and I've worked in manufacturing floors where, to reduce the amount of times they would have to send torque wrenches to the cal department, what they would have is torque transducers, mounts ones that they could have on the floor. And they would have to torque it, 5, 6, 7 times, and all of those would have to pass before they could go use that on product. Well, now, if that's how they're doing it, on a manufacturing floor, why would we ever change that in calibration, right? And all of a sudden
No,
say, hey,
and that.
conformance is
Yep.
based off of the average. So,
This
and
is this
looking
is
at
what I
it,
hate.
it's
Yep.
yeah, and that's the thing where, okay, now all of a sudden we have these standards that say this, and obviously GuideUp is not a standard, right? That would
No.
be the equivalent of, me taking a procedure from BAE and using it at Raytheon or something like that, right?
Yeah.
And
Right. Yeah. Yep.
so all of a sudden when you go to look at it, it's like, okay, well, there clearly needs to be some validation done. So when I started to look at it, I did a McNemar's statistical test to show the difference between the two conditions, right? So essentially, based off of all of these points and these wrenches, what's passing and what's failing, the individual measurements, and then compared to the average. Uh, it was significantly different. It said that these two methods aren't comparable and that they shouldn't be used, right? So it goes back to all of a sudden, well, those labs that are using averaging for conformance, like that's going to create a serious issue, especially, I'm thinking, me as the manufacturer, right? People might argue, well, their process engineers should have built stuff in to protect against this. I've seen bad process engineers base things off of cal equipment and just
Off
base it
of
off of those
averages.
limits. Yeah.
How'd you get
So
that?
so now all of a
Oh,
sudden you look at it, and if you were to look at the data, okay, let's say I got 5 points and two of them failed. Okay, well now does that mean there's the probability that for every five products, two of them are going to be torqued incorrectly? So
yeah.
how much product am I going to waste? And it goes into, but a lot of things is people like the labs I've talked to that did do the averaging. Well, it saves time and it saves money because now they don't have to adjust it. And to me, that's a lazy excuse, right?
Well,
Because
okay. Let me play devil's advocate a
sure,
little bit on here. Okay, so we're talking about averaging and everything else. If you're using a torque wrench, you do not torque the same bolt three times,
correct.
right? So yeah, replicating use is good. There are times though where I could see averaging be okay, and this is where I'm going to be a little bit of a devil's advocate. Is the ISO 17025 standard under contract review? If the customer tells you they want it based on the averages and
Then
you agree with it, you're okay. But
yes,
use some common sense. And I think this is where we're going with it. Because a torque wrench, you're not going to torque the same. You're going to over torque the hell out of the bolt if it's the same bolt and you're going to do it three times, three clicks, especially with a click wrench, making it click three times, right? On a on a bolt, that's not going to be typically be good. And I don't know anybody that's going to do that. Heck, we were talking. We don't even know. A lot of people don't even exercise the wrenches. They just go and start using them. So by the third or fourth bolt, they're exercised.
and it was Trey from NASA that actually gave me a good paper that was presented at NCLSI back in 2006 from some individuals from Italy. They actually showed why the torque wrench needs to be exercised. There's nice graphs
Mhm.
on it. And they did some great work in that presentation and document where that's why all of a sudden the ASME and the ISO documents come out and said, okay, you have to exercise X amount of times, prior to each setting, right? So,
Yeah,
and I think the original thing was they were going to go with five, but I think everyone settled on three. And I think right now, even between ASME and ISO, there's still a little bit of difference on the number of exercising, but when you look at how much they exercise and then the number of measurements they require, in total, it's almost the same number of total measurements you're taking. It's just you're throwing a few more with one over the other.
this is interesting because we were talking about that as well. Is when do you throw out data?
Never.
Right? Yeah, never.
The
Well,
assessor in me is going to say never.
the accessor in you is going to say never. The other piece of it's going to say if a
I would say
technician
be practical
be
because if
practical.
you
Yes, yeah, that's
like
correct.
okay,
Yeah,
hey, I knew something was unplugged or I'm using a bad
yeah,
cable that's frayed, like something
yeah.
I know where I'm messing it up, right? Like
Yeah.
visually, oh, hey, that cable's yeah, okay. Like, but at the same time, if you can't figure out why you're getting it and it's not acting that way, still record it, keep it as an
Yep.
observation, and you go to lunch, you come back and it's working fine. Write it up as an observation and comment and keep that data because all of a sudden, if it goes back to the customer and all of a sudden they start seeing it, well, you have the data to be like, we saw that too. That's why we put that comment in there. And okay, let's send it back in for repair. Let's try to figure this out.
Right. There's
But
situations though that we were talking about. Like if I didn't hook up all my test leads, the data that I collected is pretty useless, right? I need all of a sudden nothing. Well, if I'm doing a six wire setup, and I only hooked four up,
Yeah.
immediately I can say, oh darn, that data
In
has
that
no
case,
validity.
yeah, because technically you didn't follow the method, right? So if
Right.
you didn't follow the written method, then technically you're not doing anything at that point because now you're not following anything, right? So
Or
at that
yeah,
point, you would go back and start over from the beginning and run it through. But I did have a counter to the one point where you were saying, it's all up to the customer if they want averaging on torque wrenches.
yeah, I think it's
You
stupid, but yeah,
you
I mean,
you are right, but there is also the requirement in 17025 that it is on you to notify them that, hey, that might not be a correct method, and
right.
and then you can
Well,
also deny the work because of that, and
you
because you're
can,
like, hey,
yeah,
you're like, I'm not gonna, my lab's not gonna perform that type of work. So there are safeguards in there if your customer's like, no, that's what we want. It's like, well, no, actually, that there's like if they come to you and say, hey, we're using it for this, and here's our data behind it, and it's like, hey, okay, that's sound data. All right, we'll do it. But at the same time, it's I haven't seen enough. I mean, I had a decent enough sample size. I wish I could have had a larger one, but you know, there is a huge difference between individual measurements and averaging. That
yeah, and
y
unfortunately, yeah, we have a little bit where we average a lot, and not for conformity assessment. I'm talking about a lot of the standards that I know and I've read have take 3 or 4 series of observations. And then what do we do with those 3 or 4 series of observations? Typically, we'll put an average at the end of them, right?
yeah,
Ideally, we're going to curve fit and we're going to do, we're going to do pooled standard deviations and we're going to capture all of the uncertainty with those 3 or 4 observations, or maybe 5 if you do more. That's typically what I've seen. We have had customers that have just said, "Hey, I want you to do 3 runs and an average, and we're going to take the data and do with it what we want." These are the every what I'm yeah. You and I are saying the same thing. It's just everything needs a discussion. The
yeah,
torque one was pretty. It just doesn't replicate use. So when someone says we do 3 runs and an average for torque, you have to question it, right? You just have to say, like, that's if it's on a wrench, that's not replicating use. If they told you they did 3 runs on a cell that's used to calibrate the wrench, and then they're doing the standard deviation of those 3 runs, and they're taking the average, and they want the pass fail based on that, then it gets to a little bit different territory here because they're creating their own uncertainties, right? And hopefully they've done their own risk analysis where they know if failing it on the average is okay or not okay. We'll typically see people say, "Hey, fail it if it's 80% of spec," right? So
right.
it's a different. Not everything is black and white. I think the torque wrench one is more black and white. I'm just trying to pull all of the people are out there that might be. You pull all the examples in the air and you say, "Wait a minute, like like I have a report that's 3 runs and an average." We're not saying that's bad. We're just saying it's got to match. We got to look at the standards and look at the applications and make sure that you're accounting for all of that additional error. Because eventually, if you account for the additional error, a 4% torque wrench, you have the data, became what, a 5 or 6% wrench for it to actually be in something
Yeah,
like that.
and all of a sudden now you're masking, something that should have been a failure. So now all of a sudden you have a bunch of false accepts out there.
Yep. And that's one thing we were talking about is what do people do with that? Like, so we had an example where we had in our using our at that time it was an Agilent 3458. Now it's Keysight 3458, through eventually the instrument was so old it started as a Hewlett Packard 3458, went back, got they slapped the Agilent face on it because we broke a face eventually, and now I think when it went back for recal they put a Keysight 3458, they put their new face on it, the branding. That one's long gone, but now they're all Keysight 3458s.
I,
Anyway,
I,
yeah.
I was gonna say I love when I would work for Agilent, walking around the conferences. People would be like trying to talk to me. I'm like, no, no, that's Keysight. I'm in the medical field now. That's
Yeah, it's different
different
because
group.
yeah, that was fun. We had that discussion because I was one that was like, oh, you got to put that together. Though So we had bad data, uh, 2 weeks worth of bad data. We caught it. Fortunately, we reissued certificates because we were able to calculate a correction factor, right? You basically figured, hey, we made all these measurements. This correction factor to make them all right is this. And I was in the middle of it, so I'm like doing all the math with the correction factors and everything else, and I'm validating it with this instrument that we had, and like, yeah, this is everything's going to be within the resolution of the device. So that was 2 weeks. So we caught it. We issued, didn't have to do a recall, though at that point we had notified every customers and we had regenerated certificates, right? We had another situation. That one was pretty safe, though, because it was a 2 week window. We had another situation where we realized some of our hand weights were out of tolerance. And then when we started figuring out what that recal was and what we needed to bring back, it went, luckily, it was something that was low use. It went from like 12 to 4 people that were impact that the uncertainty was impacted, where we needed to bring it back. So that scared the crap out of me because those 4 people, how many measurements did they make with that? And if we look
Right.
at this on a global scale, like you're saying, it's only 4. Well, what if they made, 2 measurements each? Okay, it's not as bad, but then what did their customers do, and where did it get? You can I know Greg and every, you can do reverse traces, you can do all this other stuff, you can look up all this, though the main thing about all of this is what happens, and we don't typically see this in industry, or I've not seen it in industry. What happens when somebody really messes up and no one catches it? Like, say, NIST is great. They're not infallible, but they're awesome. Say NIST does a standard for somebody that just calibrates thousands of items a year, and NIST realizes they messed up. So the liability there is, okay, so NIST realizes they messed up, not saying that they have or anything, just we're hypothetical. They realize they messed up. The lab sends their standard back. NIST does everything right. They do the cal again, and it comes back. Now we have all like 1,000 some instruments that they've all calibrated how many instruments a piece, and it gets huge. And I've never seen it. Have you ever seen a recal, a
No,
recall like that?
I've seen recalls to the extent of to the example you gave, you might have to call 5, 6 customers and maybe 10 because some could be questionable. But I've
Yep.
never seen it to like, oh man, 4,000 people are affected. It's never, I've never seen it that bad, but at the same time, you know, there's a lot of labs out there that are just ISO 9001 where, no one's going in there really assessing those type of labs. Obviously they have auditors go out there and do certifications, but, a lot of these labs, they're going to try to avoid recall because they think it looks bad. But, having a good recall system is just proof that you have a good quality, management system
Right.
in place.
Hmm.
And to mitigate a lot of those issues, that's when you start to put those checks in place. And I think that's why, for performance testing, I think it's ILAC P14, starting actually January of this year, you're required to have a risk analysis with your proficiency test. You're supposed to, now rate
Yeah.
it low, medium, high. The document
Hmm.
came out in 2024, so the requirement is for all accredited labs now, starting in 2025, you have to have this risk assessment with the PT. And the reason that's going to be is if that PT is the only thing, checking that standard, then your risk is high, right? But
Hmm.
imagine you have these checks built in place, or you have control charts and all these other
Control
things that
charts
you could
are
use.
my favorite by
Right.
far. And
So,
Dylan, Greg, and I are going to work on something because they are frustrating.
yeah, but all of a sudden you have more of these things in place. Well, then the probability that you're not going to detect an error gets smaller and smaller and smaller, right? So all of a sudden you
Hmm.
catch it real quick. Okay, so you might have to notify 2, 3 people. And I imagine
Right.
places like NIST have so many processes in place to check all of this that
Yeah.
I hope you're laughing in agreement.
No, it was so funny because NIST is, I think I went to a talk by Ted Dorian, and he did a R&R. He was talking about using a uncertainty of repeatability and reproducibility. And I'm laughing because I think NIST had, I want to say something along the 60 plus artifacts that were very well characterized. So a standard lab like us may have two or three, and I think we have in most labs are lucky if you have one,
Yeah,
right?
no,
Per
exactly.
discipline, per
Yeah,
discipline. So that's why I'm laughing because this is like obscenely like yeah, you're going to have the utmost confidence, but it doesn't mean you can't. A technician doesn't make a mistake or forget something or doesn't do anything. This is like we all have confidence intervals, right? And
yeah,
someone at NIST once told me, say, hey, when you say 95% confidence, what are you really saying? And it's like, yeah, you're right. Like there's probably some error in my data set, but hopefully we've taken enough of it that we can mitigate, that we've taken enough samples. And this is why when, Dilip says single measurement bliss, one and done, that's a problem. I made one measurement. Well, what does one measurement tell you about your device? Just one,
exactly.
not much, right?
I
But
mean,
anyway,
and this is the part where you're going to go into how much you love simple acceptance, right?
no, I hate simple acceptance. Well, it depends. Okay, so I've come off of it a little bit. A lot of my bias in industry and everything when you hear me talk is because of dealing with labs and customers and just talking to people where they don't understand everything. Hell, I don't understand everything. None of us understand everything when you get down to it. And the intent of the standards is sometimes blurred a lot, or if you read these standards, they're riddled with errors. You can start chasing things like the one standard that we do a lot of work to has a shall in it, and the shall references a non-mandatory appendix. That's going to be fixed, but that's been there for like 20 years, where you can't have a shall referencing a non-mandatory appendix. You just can't do it. That's not okay. It should have been encompassed in the standard. So, or they say like a nominal 10 inches. Well, what's a nominal 10 inches if without any plus or minus? It's I went to at A2LA had a tech forum. They have it every year. I don't know what annual con they call it now. And the one assessor was up there and said, "How do I do this? How do I assess to this?" And he brought probably 10 different examples of nominal 10 inches. Well, what does that mean? He just kept going. And it is in the standards, and you hope the committees do fix them. But yeah, it is the reason I'd back off on simple acceptance is if somebody knows, and we were talking if a process engineer knows that their device, the specification is 0.1%, and they send you that device expecting you to, not apply your measurement uncertainty, and they really, and what they're doing allows for like 0.5%, five times what the specification is, I could back off of the shared risk approach really quickly because they're covered. Though what we see happening more and more is somebody says, I need 0.1%, and we take measurement uncertainty into account, and we say, okay, on the bench level, that's, we're roughly going to call it out at 90% of spec or some number, depending, the labs with the lower uncertainties get more room. So if you have a high
Right.
uncertainty, maybe you only have 50% of the spec. If you have a low uncertainty, you might get 90%, depending on your method. I'm saying bench level, which is we're just looking at that. We're not looking at a population of instruments or anything else. And I see that lab and we call it out. And guess what? I go look at that lab scope and guess what their capability is, Ryan? It's 0.1%. And every year they send it to us and every year it's out. They do not understand what's going on. If I went to their scope and saw 0.5%, there's, we could open that risk up to probably 0.2, 0.25, 0.3, and they would never, not the risk, the tolerance, and they would
Yep.
never be out. That's not what we see. We see everyone trying to push the lowest uncertainties where they can't, there's no way they can obtain them. And
I,
that's, yeah,
I mean, some labs I've seen that they try to drive for the lowest uncertainties, thinking that that's somehow going to get more business. In reality, when I've had to go out for multiple RFQs, no one cared about the uncertainty. They only cared about the price, right?
yep.
They honestly were just looking at the price, who is competitive, and all of a sudden, hey, what name do I recognize, right? And a lot of the times it was like, oh, we've used them in the past, so nope. Okay, hey, we're gonna go ahead and go with these guys. And then, I would recommend, well, these guys got a little bit better uncertainty in their process, and depending on the industry, they don't care.
It's
And
there's a lot. Yeah.
you have labs chasing it, and it's like, yeah, a lot of commercial labs. Unless you're servicing other metrology labs, trying to chase that uncertainty it it's silly, right?
Yeah.
Because now all of a sudden, someone does something 10 nanovolts better than you. In the grand scheme of things, like it's not going to make that much of a difference, especially for whatever application it's being used on. Now, I say that not knowing everything out there, but it's yeah, no, for me, simple acceptance, it's always I've hated it just because the semantics of, of decision rule, how uncertainty is taken into account, and then you're not taking it into account. I think Greg says it the best. You take all red lights into account by ignoring the red
Yeah,
lights.
you casted. Yeah, what happens
Yeah.
if, we take them, yeah, we take it into account by ignoring it, and then we'll see if we all live a year if we decide to, or if, well, not only if we all live a year, if we can spend our lives at home, because if we start running every red light, either we're going to get in an accident or we're going to get the cops are going to eventually throw our butts in jail because it's not legal.
Right.
And you're entirely correct on, I mean, just the 3.7 talks about a decision rule. It says how measurement and, a rule about accounting for measurement uncertainty. My stance on it with TAR and the other stuff is if you're not truly considering measurement uncertainty or reporting the actual uncertainty of the measurement, how do you have traceability? And if we start going with accuracy ratios, if we just start going with simple acceptance with someone saying that we had this TUR without the measurement uncertainty, I'm saying, like, I have a here's my argument. There's a lot in here to unpack, but so someone says I need a 4-to-1 TUR, and you say, okay, we're going to calibrate your devices, 4-to-1 TUR, and then they're going to say pass anything that up to the tolerance limit with a 4-to-1 TUR. So that's what gives me agita. And people say there's little risk involved in this. Your PFA is like 1.5% in this, and that's assuming global and population and all this stuff. That's where you get into, like, did you really account for measurement uncertainty if you haven't reported it? And if I have to say I had a 4-to-1 TUR, if I'm the lab that has that device and they don't report the uncertainty, and I go to do my own uncertainty budget, what do I have to use? I have to assume that lab was 4 times better than me. And if they were 10 times better than me, I can't use that uncertainty, right? Because they didn't report it. You get what I'm
Right.
saying here? There's a lot in what I'm saying that the 4-to-1 without reporting the uncertainty of the standards used for calibration kind of penalizes you, because the best I can do, if it's a 1% device, the best I can say if your lab gives me a cert that says everything was 4-to-1 is 0.25. If you were 10-to-1, I could have used zero point 0.1 in my uncertainty analysis, but I can't do that because you just told me 4-to-1. So I think measurement uncertainty needs to be reported. I do not simple acceptance. If measurement uncertainty is reported, that shifts the risk to the customer. In my experience, the customer does not. A lot of the customer base, even in when we're dealing with other like labs that have quality engineers and everything else, they don't understand this whole process is and how to do uncertainty. And I've helped a lot of them get better. Though at the end of the day, a lot of them are just like, what's the accuracy? I just need an accuracy. They're working to the Z540.1 and they want an accuracy or something else. So what do you have to say?
I mean, no, there's a lot in there. I mean, I'm in agreement with you. I mean, measurement uncertainty needs to be on there. I mean, not only just because one, the VIM says it, but for legal trade, it's required, right?
Yeah.
And I know you can report measurement uncertainty and not take it into account, simple acceptance, but there are some ABs out there. I know A2LA and both UCAS don't allow for that unless you take it a step further and show the TUR calculation. And I think there's another way where it could be acceptable. Um,
Yeah, there's
I,
different. There, like I said, there are different ways. It's just they're confusing as can get it. Let's
to me,
they're
like,
confusing to the end user. Typically, they do not understand what's going on.
and I've seen bad certificates. I've gotten certificates where the test uncertainty ratio exceeded the accuracy limits. So
Hmm.
if we're talking about, where you could have, unconditional, pass fail, and we're not just
Yep.
talking normal binary statements of pass fail. Essentially, it's, the minute, let's say it was dead nominal, it still passed in determinant because the uncertainties exceeded the whole thing. So, bringing that up with the lab, they're like, oh, I was like, yeah, your TUR, if you were to calculate it, you're upside down. I was
Yep.
like, so, but
Yep.
they're like, we didn't realize that. And I was like, so yeah, I was like, you didn't take it into account, but I took it into account, and this is a horrible, horrible cow.
It happens. I mean, we see it. I've reviewed so many certificates, and I started keeping them. I've had them where it's like zero instruments are perfect, and they say it's zero because they cut off decimal places. I've seen some where it's where someone said, "How did you know? How do you know this search wrong? I don't see anything wrong." I said, well, their uncertainty. Look at their standard. They're using like a Agilent or something else, and they're reporting an uncertainty that's 10 times greater than what NIST can get with a Joseph junction. And you're
Yeah.
like, yeah, common sense tells us you're wrong in that case. But
Well,
they don't know.
that's because
Yeah.
that 3458 was hooked up to a, cryo chamber and had a bunch of
I had one guy that had an auditor. I go, how's your uncertainty lower than ours? The reference lab that did the cal because they did it. He goes, oh, I did like a 50-point standard deviation and used that number, and the auditor accepted it. No reference standard. So
jeez.
what I wanted to say earlier though is so we wrote this book, this guidance on decision rules, and since we're talking about it, and I think maybe 50, lots of people said they'd take it and they'd edit it, and some people like gave us great feedback. So I just released version 1.3, and I found a glaring error. And what's funny is I would estimate probably over 100 have read it. Probably 50 were in the thing. Well, I'll get back and give you feedback and edit. And probably 10 of those really caught a lot of errors. And there's three of us. And the whole time, the error wasn't that noticeable, but there were three. If you have the old copy, you can look at it. There were three graphs in there that all I had done, and all the calculations were based on 5% uh, probability of nonconformance being 5%. So PFA being below 2.5 for each side, roughly. And I all the text talks about 95.45% for K equals 2. So they weren't jiving. And I had to go in but no one picked up on that. Like when you looked at it, it's like, like I said, a lot of people looked at it. Now it's fixed. So if you download the latest, you won't see it. Though every time I go through, I'd find like little tidbits here and there, we'd find it. It's just, you read through these things, and even though they're scrutinized, like I said, the ASTM standard for 20 years, people just don't pick it up.
No, yeah.
They
Well,
don't, they don't do
I
it.
mean, I point out silly things on yours. I'm like, actually, Henry, that's from a different Star Wars movie. I was like,
Yeah,
let's keep it
the
the
Death
same.
Star when I did the one. Yeah, you were the one. I was like, I stole the Return of the Jedi because it was a cooler explosion of the Death
Yes, it
Star to
was. I was
illustrate
like,
a point of
I was like,
specific
that one's
risk
from the
and
last
global.
movie. I was like,
Yeah,
the first
yeah.
one, I was like, wasn't as cool. And you were like, that's what you're pointing out? I was like, yep. I was like, sorry, the nerd in me is going to point out the Star Wars error.
And or how you spell guard band. I mean, there's so many of these little nitpicky things. Like there should always be.
Or
Um,
gauge,
Yeah,
depending on what it is.
Gauge is fun. Strain gauge is fun because BLH shipped, I think 1941, they shipped like 50,000 of them, and it was written strain GAGE. And now almost every document you see GAUGE, right? The different spelling of that. Guard band, you see guard space band in some of
Yep.
these documents.
Or
I talked
or
to
the same,
Colin.
yeah.
Yeah, I talked to Colin Delker, and I saw him writing everything he does as guard band, one word. And I said, why do you do that? All this document over here says it that way. He said, I talked to the folks at Sandia, and they told me the proper way is to spell it one word. And then I'm sitting there, I go to Chat GPT, and what's the appropriate spelling? Sure enough, it's saying, it gives me a long diatribe of why it's one word and it should be one word. So now I'm correcting in version 1.3 of ours. I'm correcting all the terminology of guard band. And I put a footnote on one, Ryan, that said, if you notice that guard band is spelled guard space band, it's because that is intentional, because when we are quoting the standard, we're referencing however the standard said it. But that creates, logistically, when you start writing papers and stuff, you want to correct standards, but then if you're quoting that standard, you should retain all the errors. I always want to add a comma in some of it, or rewrite it, in some way or form. So it's definitely fun, but they are confusing. Like the
Yes.
decision rules was the biggest one for me. It's like, we got to get something better. I
There,
think we developed something better, but yet it's not still good enough. The feedback we've gotten, well, I get it, kind of now, instead of I don't.
are you familiar with Rick Hogan?
Yeah, I know Rick. Yeah, yeah, yeah.
Yeah,
I'm certain. Yeah. ISO budgets.
yeah, with his ISO budgets, I follow his blogs. He did a good one on decision rules, just, looking at one process and then showing all the different results.
I
So,
think he did 13 of them or something. Yeah.
yeah, and and he spelt out in layman's terms like, hey, this is what this means, this is what it is, this is how you calculate it. If you want to do it in
Mhm.
Excel, this is how you do it, and then show the difference between all of them. And I was like, oh, that's actually a really good presentation about it. But to that point, there's more than 13. That's
Oh
just
yeah,
that
he did.
that
He
that,
did the
that was
common
just
ones. Yeah.
I wouldn't even call them common. Some of them I'm like, oh, I've been some of them on there I'm like, I haven't heard that in several years. I was like, but depending on the industry, right, and depending on the area, because like I said, we only deal with so much of the industry, right? So
Yep.
there
And then
there
you
could
have,
be,
yep.
yeah, there could be some industry we're unaware of in some country that relies heavily on one of those decision rules.
It could. I mean, NCSLI had a bad one for a while. We can't say all good about everybody all the time. That wouldn't be realistic. They had, what was it? One minus one over, or 1.5 divided by, I forget the rule. It was one minus TUR divided by 1.5 or whatever, it was a bench
Sounds
level
something
one.
like that.
Yeah, and then I think it was changed from 125, and then RPA 18 went into like Bayesian methods and like crazy stats to do this. And it's like, let's just, as we started the conversation, let's just get people to understand before we start chasing the highest level. I get it. We want everybody to measure within, the umpteenth decimal place, though we're not there. The majority of people are not there. They're not applying things properly. And if we could just get them to start doing things, just give them some guidelines and templates to say, just if you don't get it, just do this. This is the safest solution. And then someone will come and say, you shouldn't say that, right? You have your population, you have all that, but if they don't get it, we can't get into like two curve probability density functions. We can't get into all this other stuff because they don't understand just the absolute basics, and they're not going to get it tomorrow,
And
right? It's going to take a while.
that's some of the things I'm developing in my free time now, since I kind of have an abundance of it. Um, is you, you, Greg, you, Dillip, you guys have some of the best presentations out there, decision rules,
Thank
measurement
you.
uncertainty, stuff like that, right? But talking about measurement uncertainty, right? There's 30 courses out there. You could go
Oh
to
yeah.
any of the accreditation bodies. You could go to Dillip. You could go to Heather Wade. You could go to all
Yep.
these people, and they have courses on it. I'm going to take it back to the basics. I'm one of the ones I'm working on right now is technical writing, how to build an actual good procedure, right? I know there's RP3 out there where it tells you,
Mhm.
but no one wants to read a 90-page document on how to make a good cal procedure. Someone would probably rather sit through a 4-hour course where, hey, I'm going to provide you a template that's already designed, to be a good procedure, right? And it's going to be formatted in such a way and you can use it, right?
Yep.
And go through these courses on how, because some of the things as an assessor I go in and see, hey, they could show me these awesome budgets because they have these great tools available now, these excels, everything looks great, but then you go to look at their actual method, I'm like, 4 steps, I'm like, what the hell is this? Like
Yep.
it's horribly written, right? So And to
Love it.
the other point of that, you guys are talking some higher level. I wouldn't even say higher level, intermediate, right?
Intermediate, I think, is where
Yeah,
we're
yeah. We're not like
yeah.
you're walking into a NIST course and you're like, oh, cool, I need my PhD for this. This is awesome. Like you guys are doing the intermediate level, so I'm probably going to go back to basics of intro to metrology, but trying to also build into those steps that's going to prepare them for your courses, right? I know
Yeah, because yeah.
we do have some of those intro ones out there, but they're not as available, or they're just e-learning courses through a site where you can't actually sit there and just ask a question to someone.
Well, what I like about what you're doing is because foundationally, at one point, I said, we need all new procedures and everything else. And someone gave me a template. We created like the level what you create the hierarchy. This is going to be it, right? Your key. And they just gave me this whole template and the whole book that they were in quality and they prepared it for, and they're like, rewrite all this with the same format for what you're doing. Because you have shit, you have all this stuff and it's scattered all over and you need to organize it, right? You have paper over here, you have a book, a binder over here that, it's 2014. You have a binder that you have to go to. This is getting silly. So like, yeah, this is awesome. So that's the start, right? And then you can start understanding it and crafting it to your organization. Though the hardest thing, James Clear talks about this. The hardest thing is if you want to exercise, it's like friction points. And what you're doing is by giving them that template, you're reducing their friction points to do it. That's all I have to say. James Clear is going to say, you want to go exercise? First thing you do when you get home, if you want to go exercise and you don't feel like it, is put on your exercise clothes. Because now you have
Yeah.
you have one less friction point. But by you having that basic class and giving the procedure, you're giving less friction points for those people that are in the positions that do not know how to do it to start it. And at least and starting it is so much better than probably the scatteredness that you probably have seen on many assessments and everybody else has seen on many assessments.
Yeah. See, to that point though, I could never be a gym guy after like once I get food in my system, doesn't matter if I put my gym clothes on, I can't go. Like I got to go work out on an empty stomach.
So,
I know
well,
that's
we
not
could.
the point you were trying to make, but
No, but it's one, yeah, it's just one of the things on friction points. So it's just getting up and doing it, and it's just the starting. A lot of people don't know how to start, and all I'm saying, you give them the template, you start giving them basis of information that of which they probably will retain 11%, but they'll take home some tools. And then
yeah,
if they have that hunger, they'll start reading more. And now they'll know 20% of what they need to know. And by like a year or two, they'll be at 50, 60% of what they need to know. Then they'll start going through their organization and making changes and watching these processes. And then they'll start tweaking them and verifying and validating them, probably incorrectly for a little while. Reach out, get some help, right? Start going to the intermediate. And then eventually, in 3 to 4 years, they should be humming along. But you don't change the point is any of this is you can't just change it all overnight, and that's yeah, and people need to start. By not
yeah.
starting is a problem.
Yeah, I mean, one of the other courses I want to focus on is continuous process improvement for CAL
Hmm.
labs. I know it's difficult, but I mean, talking about, some labs, they'll look at it and they'll look at piece count coming in. But if you think about it, commercial lab, say, regardless of the size, you got 10,000 pieces a year, you got 400,000 pieces a year. They're not all apples coming in, right? They're
Nope.
they're all not going to take the same amount of time, but they try to base labor and try to project hours based off of, okay, I'm expecting because of last year, I had 40,000 pieces this month. I'm going to need, it's going to be the same thing. When in reality, not everything's on a 12-month cycle. You have, customers that are on whatever cycles, 2-year cycles, 60-month cycles, 6 months, whatever it is, right? And if you know the actual time it takes to calibrate those items, instead of looking at the piece count, now you can look at the hours coming in. And then you can take worksheets that Greg's developed that help you, look at, okay, hey, I now know how much time is coming in. How many people do I need? Okay, well, I can't.
Yep.
afford more people, but I can afford overtime. How much overtime do I have to put in? So, start to teach those, things as a continuous process improvement where they can then look at that and then leverage things that you and Greg have developed where, okay, hey, I'm not going to look at a piece count. I'm going to look at it, hours coming in.
Yep. You can look at machine time, and you can look at, yeah, Greg has it, the PERT formulas and everything else are all good. And creating buffers on what I'm going to need because uh,
Yeah, Greg's got great
rarely,
tools on it. It's now
yeah,
just teaching the labs to get to that point, right? And
well, yeah,
having them stop viewing everything as, okay, we got X amount of assets coming in. It's like, okay, that's great, but how long are those going to take? Because an RFPs could take 10 hours,
yeah,
where
you
you
don't
could have a
know.
torque wrench that's going to take you 20, 30 minutes if
Could
it's
take you
already set
10
up.
minutes if you need to do if you're just doing the averages and reporting it, maybe it takes you 10 versus an
Yeah,
hour to adjust it
exactly.
and reset the mechanism. Yeah, there's a lot of stuff in there, and running a lab's difficult because not everything works. It's not like you just put it in a machine and magically it works. There's a lot of discussion. Customers don't care for their stuff. There's a lot along the way that, and it's almost like you're Sherlock Holmes at times. What changed? I have 5 years of history, and this thing doesn't look like it did today. So, what changed? And then you got to do some research. You'll find out that someone removed something or they shifted something, or a lot of times we're relying on technician notes with it. Like, hey, this is talk to the customer, just getting the system down and everything else. We have a whole wiki page on every instrument that we calibrate where there's notes, all the customer contacts, and they say, oh, this customer wants this loaded this way or this loaded that way. And it's like, okay, well, that's 5 years of data. Guess what? Our guy didn't see that note. We go back. This is what I was talking about throwing in data. The guy, he sees the note and says, oh, I loaded it completely wrong. And you have good data there, but only if it's loaded the wrong way. So you have to
Right.
redo the cow. And that's an internal rework that usually caught on. It's sometimes why you have the two-level checks, right? You have the technician and then quality manager or lab manager, like two people signatories
There there
on the
was
certificate.
There was one lab I used to work at when I was a technician, and you get the work order, and some of them, it's just one sheet, no notes, and you're good. Other ones, it'd be four staple, five staple pages, and it
Hmm.
would just be notes on notes. But there's accounting notes in there, there's sales notes, so there's all these other notes, and then there's a small section about the technician note where something might need to happen, where it's like, oh,
That's
if
all you
it's
want.
yeah, if
That's
it's
all you
more
want
than
in the Cal Lab. Yep.
exactly like, you know, it, some labs were good, they would make sure that they would highlight it, but then that's still someone going through and highlighting all that stuff, right? And then, it's a customer where what they want is if it, let's talk about torque again, right? It's 75% of error. They want it adjusted back,
Yep.
towards nominal. Okay, but you miss that note. All of a sudden, you send that back, and they see it wasn't adjusted. Now you've got an upset customer, and what do you explain? Well, sorry, we had a four-page paper that they had to read through, and they missed these four sentences out of
Seen
this
it. It's in the fine
bibliography.
print. We've missed it. We've missed it in the fine print too. Well, where is that?
And
It's
the
on
crazy
page
thing
eight
is,
in the fine print. And it's like, okay.
and the
Uh-huh.
crazy thing is, if you go through a continuous process improvement, or even just in this case, if you were to treat it as a kappa or
Right.
CSR, whatever you want to call it, right? Whatever terminology we're using for the corrective action, it should point to the software, not the technician. It should point to, yeah, the tech didn't catch it, but you make it really hard for the technician to catch this, right? So it should be one of those things like, okay, hey, we need to make this a little bit better for the technician, right?
Put it
And
put it in a section. Like here are notes for the technician, really big. Do not put it in a footprint. Do not bury it on page four.
yeah, like
It
if it's
probably
printing
should
for
be,
if it's
yeah,
printing for a work order, the only note that should be on there is technician notes.
yeah.
Like accounting
And,
and sales and all that other
yeah,
stuff should not really have to worry about it, because
yep.
that's the piece of paper that the tech's following around with.
Right? How I calibrate, well, what we want the time that the customer expects it back because that's important if somebody said something, and how to calibrate it. What are your expectations? You want it adjusted at 75%? Put it right there, big, like a acceptance criteria. Put the decision rule you want on there if you can put it on there. If you're willing to accept what the lab offers, then that's fine. Put where you want your adjustment criteria. Put all the other stuff that you want on the order. Don't bury it in page five or page four because that's as a technician, which you and I have both been technicians. it's hard enough. You're trying to juggle all these instruments coming in, and we only do force and torque. And I know some technicians switch benches and they do everything else, and it is hard to keep all the notes, everything else. Before we had this wiki, we had a card file that, index cards back
Yep.
in like the 80s. So everything was serial number with an index card. You pull out the index card, you'd write a note, something would come in, you'd have a note. Now we get pictures, we can embed pictures, we can do all this other stuff. And then one of our worst ones that people don't pick up on in contract review, and I'll say that, and we got to jump off because we're going for a while. One of the worst ones is when they change the criteria. Someone's done something one way for 10 years, and then they stick it on like page 3 or 4. Oh, by the way, I want you to change the criteria. Well, guess what? The technician gets biased by the previous. They start looking at the previous data. Oh, they wanted this way. They look at their notes. That's a hard pickup for a tech, especially when they're trying to cycle work through. So I love what you're saying. It's just make it idiot proof. Put it real big on the front page, like what you want. Highlight it, bold it, do this, do that. I know. Send a different page. If the system doesn't allow you to do that, copy and paste it out of your whatever system that you're using and send it with the instrument in the box so the technician can see it, hopefully, because
I
it's
mean,
gonna get you what you want as the customer.
and most CMMSs now will do that. So, whether it's Met Team, IndySoft,
Hmm.
I mean,
Yep.
I've played around in Infor, Blue Mountain, Maximo when I was healthcare. I mean, you can leverage those systems a lot better than, a decade ago, right? So,
Yeah.
to these points with contract review, when things change, these systems should be able to work to your advantage so that the technician, I think of it, in the military, like when I was a Lance Corporal Junior, it my day was, already planned out for me. Hey, I'm going to go in there and I'm going to get assigned work, and that's all I'm going to do till about 4 o'clock, right? And if I get done with my work early, I'm going to go to the sergeant in charge or corporal and be like, hey, I finished my work. Okay, cool. You're going to go do this now, right? It was idiot proof. I didn't have to think about it because then when I had to pull up a thing, I type it in MetPro, the software we used. It would say, hey, this is the procedures you can use. Oh, you don't have this standard. You clicked on it. It would tell you what your suitable standards for substitution were. Oh, yep, I've got that one. Cool. And you're on the bench and you're done. And like
That's awesome. Yeah,
it made
that's
it,
phenomenal.
and like people would always complain like, oh, military must have been so hard. I was like, actually thinking back on it, I was like, it if you were junior level, it was the easiest thing ever. You got paid and someone told you what to do, and
And you
you
did
had
it.
to, and the worst part was maybe you didn't like running, you had to go run sometimes. But a lot of the times we just went and played football. So
That's awesome. So I cannot thank you enough. We could talk forever. We're supposed to go for this might become a two-parter for those that are listening, but yeah, I cannot thank you enough for coming on and spending some time with me. If
absolutely.
people want to connect with you, it's Ryan Kelly on LinkedIn, the best way,
Yes.
or any
Uh,
other way
my
that.
my email is rpkelly, so that's Kelly 919 at gmail.com. Easiest way to reach me, or like you said, Ryan Kelly on LinkedIn. We're connected, so they can go through your profile to find me.
Yep.
It's public,
Yep.
so it shouldn't be an issue. I know there's a lot of Ryan Kellys out there, so
And there's an R. Kelly out there. Let's not go
ooh, ooh. You
there.
know,
Well, we have a Ron Kelly in our who's going to come on this, and yeah, his email is because we did first initial last name. His email is rkelly at mhports. That's not Ryan's email.
I've I've been places before where they're like R. Kelly. I was like, guys, can we do like first two initials? They're like, this is way too funny. No. And I'm
No, no,
like,
but you.
oh,
This is from the guy that likes to sing Afro Man in karaoke. So
I don't know what you're
yeah,
talking about. I've
I
never done
yeah
such a
yeah
thing.
yeah 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 yeah
Uh,
yeah. So
Hey,
yeah, thank
if it wasn't
yeah.
recorded, it didn't happen.
Oh, I think someone has it somewhere, but so yeah, thank you. Get in touch with Ryan. Internal audits, Ryan, ANAB assessor, maybe some other accreditation bodies in the future. We don't know. We didn't talk about that.
I
And
also offer consulting services on the side. If people need
consulting
help with their
services. You
programs or quality management systems, I'm available for that too.
need internal audits. That's another service that we were talking about with Dillip. Dillip's
Yep.
not able to do them all. All these other people are not able to do all. So here's someone that can. I would highly recommend to come and do internal audits. I cannot wait to get him to come in to do ours. Dillip just did ours, so hopefully we'll have that soon. But yeah, thank you, Ryan.
Absolutely. It was a pleasure. Thanks for having me
Yeah.
on.